I'm Mike McDonald from Huawei Technologies, and welcome to the Seeds for the Future course on artificial intelligence. What we just saw in the cartoon is a car with a level 5 of artificial intelligence. A very strong level 5, actually. Cars like that don't exist yet. However, AI is now very common in daily life. In some homes, people adjust the heat with their voice. Online businesses like Amazon learn from what you bought before, suggesting other things that you might like. At Huawei, we use AI extensively throughout our operations. The AI we use isn't nearly as sophisticated as the androids you see in science fiction movies like Star Wars, but it's of great help in running the company. Let's watch a short clip.
AI is increasingly common in our lives. But what can it do for companies? At Huawei, we use narrow AI, or context-specific AI, to take care of repetitive, labor-intensive tasks and allow our staff to focus on more important work. We use narrow AI extensively throughout our operations. For example, we use it to manage our shipping of hundreds of thousands of products daily to customers worldwide, or perform standardized administrative tasks like processing reimbursement claims at our offices in over 170 countries. And we use AI to assist our engineers to perform network deployment and maintenance, including site surveys, equipment installation, and QC. On our production lines, AI helps to boost productivity. It's like having thousands of digital assistants working alongside our actual staff. In total, we use AI in over 200 of our company processes.
Now let's go back to the basics. What is AI, and where does the idea come from? Humans have envisioned autonomous machines since antiquity. In Greek mythology, Talos was a giant bronze automaton, a kind of robot that would tirelessly protect the goddess Europa on the island of Crete by throwing huge boulders at pirates and other invaders. Man-made things that think on their own have also been a standard theme in movies or literature for centuries. You can think of Frankenstein, a novel by the English author Mary Shelley. Believe it or not, that was written over 200 years ago. In the real world, development of artificial intelligence has gone hand in hand with that of computing power. At first, computer scientists debated whether machines could think at all. Alan Turing was a mathematical genius who during World War II built a computer able to decrypt messages encrypted with Germany's Enigma system. In 1950, he came up with the Turing test to address the question of whether machines could actually think. His idea? If a machine could fool a human, then a machine could think. The Turing test for artificial intelligence goes like this. A person tries to correctly differentiate a human from a machine by sending text inquiries and judging the reply. When the person misidentifies a machine as a human, then it indicates that that machine has the ability to think. Needless to say, no machine in Turing's days passed the test. Let's turn to another pioneer of AI, the American computer scientist John McCarthy, who in 1956 first came up with the phrase artificial intelligence, or AI. In 1958, McCarthy invented Lisp, a family of programming languages still used in the development of artificial intelligence. Lisp set the stage for the development of intelligent devices and robots able to operate independently. In 1966, McCarthy developed the first chess-playing computer. A third AI pioneer is Marvin Minsky, also an American computer scientist. In the 1970s, Minsky proposed the Society of Mind theory. The theory says that what we call intelligence could be produced by the interaction of non-intelligent parts. And he provided a definition for AI as the science of making machines do things that would require intelligence if done by men. Perhaps you thought that creating advanced AI mostly involves computer science and software coding. But making machines think like people actually combines at least 7 disciplines that normally don't interact. You need to coordinate many people with very different backgrounds who don't always understand each other. This can make developing AI very complicated. AI development also harnesses tools like pattern recognition, machine learning, and statistics, to name just a few. You might be surprised to hear that statistics is used in artificial intelligence. But according to experts, it is essential for collating the data that are fed into AI systems. This brings us to the topic of how machines learn to be intelligent. This chart shows the relation between AI, machine learning, and deep learning. Deep learning is a subset of machine learning, which is itself a part of artificial intelligence. Machine learning and deep learning are both about designing methods for computers to acquire new knowledge and skills. When you hear AI algorithms, it's related to machine learning. Deep learning is a newer part of machine learning. Deep learning aims to simulate human-like intelligence in machines, particularly the ability to interpret data like sounds, images, and texts. Deep learning emerged from research into artificial neural networks, or ANNs. ANNs are computer systems modeled after human brains. In an ANN, artificial neurons send signals to each other, much like biological neurons do. Let's end this part with a quiz. What are the 4 things you always need when creating an AI system? Can you think of what those 4 things are? Maybe you need a clue. I'll name one of them and let you think about the other 3 for a few seconds. All AI systems include learning algorithms. What are the other 3 essential components of all AI technologies? I'll give you 5 seconds. Okay, the 4 things you always need for any AI system. You need 1. Learning algorithms, as I just mentioned. 2. Computing power. 3. Data. And more is always better, by the way. And 4. AI application scenarios. Because, of course, there is a goal for the AI to learn. It must learn in order to accomplish a specific purpose. If you guessed the 4 essential elements, very well done. It wasn't easy. Okay, we're finished with this section of the course. Let's move on to the next section.